Welcome to the next video from lesson 2.1 and 2.3. We're going to talk about how we find extrema, maxes and mins of a polynomial, and how we find zeros or x-intercepts. So we have this theorem. It kind of has a fancy name, but in the end it says that a polynomial of degree n has at most n minus 1 maxes and mins, and at most n zeros. So this is kind of what we call an existence theorem. It doesn't tell us exactly how many. It just tells us that we can expect at most this number. So if our degree was 4, we might expect to see 3 total maxes and mins, and then 4 x-intercepts. But it doesn't mean we have to go that high. It could be lower. And as you go through some questions, hopefully you will see that. So our first example, we're going to find the zeros of 2x cubed minus 4x squared minus 6x. So we want to find those and then sketch a graph of what this looks like. So you've been doing the first part for quite a while. It just means set the equation equal to 0 and then figure out how you can kind of break this apart or factor it apart. So one thing I notice here is that every single chunk has 2x as a factor. So I'm going to take that out of everything, and I'm left with the 3 parts that are in the parentheses there. And now that's just a quadratic. We've been practicing how we break that apart. 2 numbers that multiply to -3 and add to -2. And those 2 numbers would be -3 and +1. And then from there, the 3 different chunks, the 2x, the x minus 3, and the x plus 1, we have to think about what would make each one of those equal 0. And we get values of 0, 3, or -1 for x. So now we know what our x-intercepts are. We also go back up to the top and we can think about end behavior. We know that because the leading coefficient is positive and the highest degree is 3, we know it should go up on the right side and down on the left side. So we kind of put all that together. This would be our graph. We have x-intercepts again at -1, 0, and +3, going up on the right side, down on the left side. So that's probably something that maybe you're familiar with already. I think our next topic here will be a little new. Okay, we're going to talk about a term called multiplicity. So when we have these x-intercepts, sometimes when we factor them apart, the same x-intercept could appear multiple times. It's not common, but if it does, we can say something a little bit more special about what these x-intercepts will do. If we see that that this x-intercept appears an odd number of times, what we're going to see when we graph it is that the function actually crosses through the x-intercept there. So it will go from the positive side of y values to the negative side, or vice versa. But if that x-intercept, or if that 0 occurs an even number of times, graphically it's actually just going to touch there, but stay on the same side of the x-intercept. So let me show you a couple of examples on there through Sketchpad. Okay, we're looking at the equation x plus 3 to the first and x minus 4 to the first, and you can see that the zeros will be -3, so right there it goes through, and at +4 it goes through. Notice that the y-axis is scaled quite a bit right now. That's why it looks a little distorted. But if I were to take the power that goes with the 3 there, the x plus 3 part, and I square it, now this part has not changed. That's still going to go, that's still going through because the power is odd. But now my power here is even, and I see that at that x-intercept it just touches and stays on that side. And I can also look up here and say, well, this is an x with a power of 1. This is going to be x with a power of 2 when I go through and FOIL it. So altogether, this is like x cubed, and we can see that, yep, it's going up on the right side, down on the left. And as I were to continue dragging this, the pattern still kind of continues. Now, this again has a power of 1, it's going to go through. This has a power of 3, it's going through as well. And notice it kind of looks like x cubed right there. If I were to go one more, okay, now we're at x to the 4th here. It's got to go up on the right side and down on the left side, because overall this would be like x to the power of 5. And it's got to go through and then just touch or just graze right there and then go down on the left side. Okay, we can do the same thing with what we see with x to the 4th. Okay, so now x minus 4, that's being squared. It's just going to touch right there, and it's going to go through at -3. And as I kind of draw this over, Now power is 3, so it's going to go through there and also go through there. Overall, the power here would be 4, so up on both sides. So that's just kind of a unique thing to look at there. Can it be helpful? Sure. I want to look at one more example with you related to that before we wrap this up. Okay, so in our last example, we want to sketch the graph of x plus 2 being cubed and x minus 1 being squared. A couple things to note. If we were to FOIL this together, the highest degree would be 5, so it's going to be similar to x to the 5th up on the right side, down on the left side. And because I have negative 2 being a 0, and the degree of it is odd, it's going to actually cross at negative 2. And for x equals 1, for that 0, the degree is even, so it's just going to touch at that point. So when we graph this, I know automatically it's going to go up on the right side, down on the left side. I can mark in my x-intercepts and then figure out how to connect everything so that it works from there. So here's a graph of what it looks like. Up on the right side, down on the left side. The power at 1 was even, so it's just going to touch there and stay on top. You don't necessarily need to get your y-intercept of 8 or know that the max is there. You just need to show that it's positive right here. Okay, and then at negative 2, it was an odd power, so it's going to go all the way through. And again, I don't necessarily care if it looks exactly like this there. As long as you're showing that it goes through at negative 2, that's the most valuable part. So we're going to stop right there. See if you have any questions on these examples.